Assalamu alaikum students. Today our topic is regarding resolution of vectors. Resolution of vectors, you can say also say it decomposition of vectors. As we have read addition of vectors. What was done in addition of vectors? We were having like this as a vector and this as another vector. Then we have to add them up. And what we did, we then did it like this. We put it first vector like this, then displaced second such that tail coincides with the head of first. Then the vector drawn from the tail of first up to the head of second or last one, that was known as the resultant vector. Now what, yeah, you can say this as a composition of vector. Now we are having the resolution of vector, splitting of a vector, or you can say simply decomposition of vector. What is first the resolution of vector? The process process of splitting of a vector into its components is known as resolution of vector, or you can say decomposition. But first let's first understand it out what actually it is. Now we are having a single vector, this. In the first case we called this variable as a resultant vector. Now we are having this as a resultant vector. We have to split out this way work into its component. Let I will say if a person takes some load something from this to this, that very load is now carried by some another persons, and they are not having the capacity to do it in one go. That among the one person that's moving that very load in this very direction, and then another person moving the same load in this very direction. So I can say this very r, whatever work is done by this very person, same work is done by these two very vectors, vector a and vector b. So the process of splitting of a vector, now we have to split out a single vector into its components. Along this very direction, there will be only a one component. There cannot be another. Up to from this point up to this. If you are going to go again in this very direction, up to this very point, again in this very direction, up to this very point, your magnitude cannot change, neither can change your direction. But if you are going to go beyond this very point, here, your magnitude changes. Although direction remains the same, but your magnitude changes. So in a particular direction, once you are going to go through resolution, splitting of a vector, in a particular direction, it is having a particular component. And that's called as the uniqueness of the component. This a and b, these are the components of r. So I'm simply saying what resolution, what about you, what you have to understand from resolution of vector is the process of splitting of a vector. This very vector which we are having initially, we have splitted up it into components, and those components are a and b. And in a particular direction, once it's going to go from here to here, it's having a, it you cannot have in the same direction, and up to the same magnitude, you can't have there are different values for a, you can have only a single value for a, and this is called as simply resolution of vector. Now this resolution is of another, we can have these types of the resolution, and one among the type that we have to read here, which is very much important, that's called as the rectangular resolution. Rectangular resolution. Rectangular resolution of a vector. What do you mean by rectangular resolution of a vector? Simply, now we have to split out a vector. Let's first take the example, then I will place the definition. We are having this as a vector. Let this be vector r, a, yeah, whatsoever argument, let it be a. Vector. Now in this plane, we will make a plane. This is the x-axis, and this is the y-axis, and it is inclined at an angle theta with the x-axis. It is the vector, its magnitude is a. Now we have to resolve it into its components. this is x-axis, and if I will say, if I will draw a perpendicular here, another perpendicular on this very axis. Now I will give components. I will say the component of this very vector along this axis, x-axis, I will put that ax. And I will again say the component of this very vector along this very y-axis, I will put that ay. As I have completed the rectangle, if it is ay, then this will be also ay. If it is ax, then this will be ax. Now, if you are going to see into this very by triangle of vector, you can say vector a equals to ax. But as this is in the x-axis, then you have to say it axi plus. It is in the y-axis, so you have to say there is a unit vector which is there, that is a y of j. So this is the vector a. We can replace, this is the vector form of vector a. In its components here, the ax is only the magnitude of vector a along x-axis, and ay is the magnitude of vector a, the component of magnitude along y-axis. So completely we can say a vector magnitudely we can say vectorly we can say axi plus ay g. What are ax and ay? Ax and ay are the components of vector a along x-axis and y-axis. So this is the vector form of what? This is the vector form of vector a, unit vector form, actually unit vector form, unit vector form. Now we can here also calculate magnitude also. So this very resolution, first of all you have to now understand rectangular resolution. This very resolution of a vector in which it is components, as these are called a component. Here a and b were the components of r. Here ax and ay, these are the components of what? Vector a. In which the when components of vector are perpendicular to each other, as ax and ay they are perpendicular to each other, then when components of vector are perpendicular to each other, then resolution is rectangular. Then resolution is rectangular. It is called as rectangular. So what is rectangular resolution? A resolution is said to be rectangular resolution if the components of the vector are perpendicular to each other. Now if we have to calculate what will be the magnitude of a, so magnitude of a we can calculate like this. In this very triangle we can have the relation there, we can have sine theta as well as the cos theta. From this very triangle, from the given triangle, from this very right angle triangle, we can have sine theta is equal to perpendicular, that will be simply ay by a, and cos theta is equal to ax by a. Now if we are going to square them and add them, then it will be simply like this. If squaring and adding, we will have sine square theta plus cos square theta equals to ay by a का whole square plus x by a का whole square. So I will take it like this: sine square theta plus cos square theta, that is simply 1, which implies 1 equals to, it will be ax ay square plus a square plus x square plus a square. This a square will be common, then it will be on this very side. Simply a square is equal to x square plus ay square, or a is equal to under root of x square plus ay square. So if you have to calculate the magnitude of a, magnitude of a is not simply equal to ax plus ay. it is equal to the under root of square of the magnitude of one of the component plus square of the magnitude of another component. Listen carefully what I am saying. I am saying if we are having this as a this as vector a, let this vector a be, I will take the example so that you will get it out. If it is 4 Newton and it's making an angle of 30 degree here, so here the component will be 4 because it is having a 4 cos theta cos of 30, and here it will be having a component of 4 sine of 30 because with the base the perpendicular this they are having a relation of ax by ax by that's cos theta, that's ax is equal to, which implies here ax is equal to a cos of theta, or which implies here ay is equal to a sine of theta. As this was ay, so this is ay, it will be 4 sine 30, it will be 4 cos 30. So now if we have to calculate, if you have to say how much will be this 4 cannot be simply equal to 4 cos theta 4 cos of 30 plus, we cannot place 4 equals to, it is not such, we cannot put 4 cos of 30 plus 4 sine of 30, but 4 is equal to under root of this square, that is 4 cos of 30 ka whole square plus ay, that is 4 sine of 30 ka whole square. We can calculate it out. It is sine 30, it's cos 30, so we can calculate it out. This will be equal, so simply the magnitude, this is not equal to 4 is not equal to 4 cos 30 plus 4 sine 30. So simply this is the rectangular resolution. Rectangular resolution means simply once we are having the resolved components and those very resolved components are perpendicular to each other, then the resolution is said to be what? Rectangular resolution. This is all for today. Tomorrow will be with another lecture. Till then, Allah Hafiz.